Hi, this is Andrea Hendricks. I want to talk to you about how you can graph polynomial functions by hand. Specifically, we will look at some factored forms and try to solve equations and inequalities from the graph that we obtain. So let's look at how to sketch the graph of this function f of x is equal to x plus 1 times x minus 2 times x plus 3 by hand, and then we're going to solve where f of x is equal to 0, f of x is greater than 0, less than 0, greater than or equal to 0, and less than or equal to 0. These things we've done before looking at the graph, so that should be nothing new to you. So what I want to start with graphing, the first thing that we need to find are the x-intercepts. That is where x plus 1 times x minus 2 times x plus 3 is equal to 0, right? The x-intercepts are where y is equal to 0, and actually by finding these, we will also find the solutions to where f of x is equal to 0, because graphically those are just the x-intercepts. So if I do that, remember that when you have a factored form set equal to 0, you just want to set each factor to 0. Please don't try to multiply this out, because you will undo the form that you actually need. So we would have x is equal to negative 1, x is equal to 2, and x is equal to negative 3. So right away we know where it's going to cross the axis. It's going to cross at negative 1, at 2, and at negative 3. Okay? Now, another key point on a graph is the y-intercepts. If you want to find the y-intercept, remember that's where we find f of 0. F of 0 is plugging in 0 for x, and then we get these three factors, so we can simplify inside to get a 1 times negative 2 times 3. Multiplying those three factors together gives us a negative 6. So we know 0, negative 6 is also on our graph. So at 0, we go down 1, 2, 3, 4, 5, 6. Okay. Now, do we know anything else? We've talked about the basic shape of polynomial functions and what should happen on the ends. Well, we know that here, even though this is not a polynomial function that's been expanded, but if you think about multiplying this out, what you would really do is look at the terms that involve x into each of those factors. X times x times x, if we multiplied that together, we would get an x cubed. That has a positive coefficient, so that means the graph is going to look like the basic shape of that x cubed at the end. So in other words, it's going to be down and then up. So we know that to the left of negative 3, our graph is going to be down. We know that to the right of 2, our graph is going to be up. Okay? You don't really have to know specifically what those are. You certainly could plug in some points to the right and to the left to find that out. But if you know the end behavior, you know enough to get the general shape of the graph. Well, we also know what's happening between the negative 1 and the 2, right? Now, understand, this is just a rough sketch by hand. If you actually had to find the relative max and the relative min, you would need to use a calculator to find out exactly where that occurs. But just to get the basic shape, we know that between the negative 1 and 2, it's going to come down and then back up like that. Okay? So we need to know what's happening between the negative 3 and negative 1. We suspect that it's going to go up and then come back down, but let's just confirm that. Well, to find a point between negative 3 and negative 1, I would have to plug in a value of x between negative 3 and negative 1, let's say negative 2. So if I find f of negative 2, I would have negative 2 plus 1 times negative 2 minus 2 times negative 2 plus 3. So that would give me a negative 1 times negative 4, right, times 1. We multiply those together, we would get a positive 4. So we know at negative 2 it's going to be 4. 1, 2, 3, 4. So, like we thought, it's going to come up to that point and then come back down. Now again, it could go up higher somewhere else in that region, but we're just going to try to get the basic rough shape of the graph. Okay? So And all we need really is where it's greater than or below the axis. So we have enough information to find that because of these points that we've obtained. So for part A, where are the solutions to f of x is equal to 0? Well, f of x is equal to 0 at the intercept points, which would be at -3, -1, and 2. Part B is where is f of x greater than 0? Well, f of x is greater than 0 where the graph is above the axis, right there and here. So that is between the -3 and -1 and to the right of the 2. Remember that you're answering with regions of x, the intervals for x. Here another way you could do this, right? Do you remember the number line method? You could plot your points that you found for where it's equal to 0 and then test points out of each region to find out the solutions to the inequality. That would be fine too. Part C, where is f of x less than 0? Well, less than 0 is where the graph is below the x-axis, which is to the left of the -3, so -infinity to -3, and then between the -1 and the 2. Part D is where is it greater than or equal to 0? Well, that's only including the points where it was greater than 0, right? So for part D, we're just going to include the endpoints. So that would be from -3 to -1, union, bracket 2 to infinity. And then the last part is where is it less than or equal to 0? And that is at -infinity to -3 with a bracket, union, bracket, -1 to 2. Right, because at those points we get to include where it was actually equal to 0. Okay? So just to review here, we found the x-intercept, we found the y-intercept, and then to get more detail with our graph, we found points between the x and y intercepts if we needed them. Now here's a graph to sketch by hand. It is known as a fourth degree polynomial because there are 4 factors and its coefficient that's leading is a negative. So that means that its end behavior it looks like that negative x squared. That is, both sides are down to the left and to the right. So what we want to find is first the x-intercepts, and that is where -3x times x plus 2 times x minus 5 times x minus 1 is equal to 0. And that is found by setting each of these factors to 0. So that occurs at x is equal to 0, right? If we divide by -3, we get 0. We can subtract 2 to get -2. We can add 5, and we can add 1. So our x-intercepts, or the solutions to where f of x is equal to 0, are at 0, -2, 5, and 1. Now, our y-intercept is f of 0. Right, plug in 0 for x. Well, we actually don't have to do this, but I'm going to show you the steps here just in case you don't find this from the first step like we did. Do you notice how one of our x-intercepts was at 0? So that means the origin is also the y-intercept. But that's true because if you do -3 times 0, you get 0, and 0 times anything else is 0. So we really already knew that 0, 0 was a y-intercept. Now we also know the end behavior, right? We know what's happening to the left and to the right of those last intercept points. So we need to find out what's happening between these others. So that is between the -2 and 0, 0 and 1, and 1 and 5. And so we need to find out for value between -2 and 0, let's say for -1, what is f of -1? So if we plug that in, we get -3 times -1 times -1 plus 2 times -1 minus 5 times -1 minus 1. what would that be? Positive 3 times 1. Negative 1 minus 5 is negative 6. And negative 1 minus 1 is negative 2. So that would be a positive 3 times 12, which is a 36. And you can use your calculator if you need to find out that particular point. So we know at negative 1 our graph is at 36. So that's probably going to be way off our graph, right, unless we change our scale. Maybe our scale is 4s. So if we count by 4s, we would have 4, 8, 12, 16, 20, 24, 28, 32, and 36. So let's call that negative 1, 36 there. So we know what's happening here. It's going to come up and then come back down. So we need to figure out what's happening between the 1 and the 0. Okay, maybe that graph here's a little bit more vertical. Okay. So between 0 and 1 is 0.5, right? So we'd have a negative 3 times 0.5 times 0.5 plus 2 times 0.5 minus 5 times 0.5 minus 1. So that's a negative 3 times 0.5 times 2.5. 0.5 minus 5 is a negative 4.5. And 0.5 minus 1 is a negative 0.5. So if we multiply all of those together, definitely on the calculator, what is that? Negative 3 times 0.5 times 2.5 times negative 4.5 times negative 0.5, I get a negative 8.4375, so we'll just call it negative 8.4. So since we're counting by 4s, we'll go down 4 and 8, and a little bit more than that. Okay? So it's going down and coming back up, so we would expect it to go up again and come back down. So we need to find something between the 1 and the 5, so let's do maybe f of 3. So if we find f of 3, we would have negative 3 times 3 times 3 plus 2 times 3 minus 5 times 3 minus 1. So that's a negative 9. 3 plus 2 is 5. 3 minus 5 is negative 2. And 3 minus 1 is 2. So what is that? Negative 45 times negative 4 is a positive 180. Okay, so we're really off our scale here. But so that's going to be, at 3, it's going to go to 180. So just use your imagination and say that's 180 here. So it's going to go way up, and then it's going to come back down. Okay, and that's going to be the basic shape of the graph. Okay, so we can use a graph to answer these questions. Where is f of x equal to 0? Well, that is at 0, negative 2, 5, and 1, right? Where is f of x greater than 0? So greater than 0 is where it's above the axis here, and also here, right? So where does that occur? That occurs between negative 2 and 0, and between the 1 and the 5. So that would be from negative 2 to 0, union 1 to 5. Okay. Now, where is f of x less than 0? Less than 0 is to the left of the negative 2, between the 0 and 1, and to the right of the 5. So we would have a negative infinity to negative 2, union 0 to 1, union 5 to infinity. Okay? So that is the solution to where f of x is less than 0. Where is f of x greater than or equal to 0? Well, now that just includes our endpoints, right? So that would be at -2 to 0, union 1 to 5. And lastly, where is it less than or equal to 0? That includes the endpoints where it's less than 0, so -infinity to -2 with a bracket, union bracket from 0 to 1, and then bracket, so let me erase this point here, then bracket 5 to infinity. Okay, and that's a union symbol right in there. Okay, so did everybody follow what I did there? I found the x-intercepts, or that is the solutions to where it was equal to 0, found the y-intercept, which happened to not be different than what I had already found from part A. Then I had to find some points in between those intercepts to determine what the graph does. Does it go above or below the axis? And then I used the graph to find the solution to these inequalities. Okay, and again, I could have done test points on the number line if I wanted to do that. So what I want you to do is see if you can work these problems. F of x is equal to x plus 1 times 2 minus x times x plus 3. F of x equals x minus 1 times 2x minus 5 times x plus 2. And then the last one is f of x is equal to x times x plus 2 times x minus 5 times x minus 1. So use your calculator to help you if you need to, but the goal is to try to get as much as you can do as much as you can by hand, and then if you need to, use a graphing calculator to help you fine-tune some of those points. Okay? Contact me if you have any questions. Thanks.